is Ramesh, this is Srikant and Gajanan. We three have been running this meetup group. And this group is focused specifically on data security and data governance. Sorry. So, and this is the first time we are holding a meetup in this fantastic location. So I'm also getting used to this, all the facilities here. So, first of all, thank you all for coming here and making this meetup group interesting. Then I would like to thank Tomar for agreeing to talk in this group because we have a very specific topic. This group is related to really a niche, data security and data governance. So there are really few experts in the valley who can talk on those topics, and he has agreed to talk. He's one of them. He has agreed to come and talk to us on that topic. That's a great thing. So thank you so much. And in fact, interestingly, we have our last speaker, Balaji. He's one more expert in security area. He's also present here today. So I would like to thank all the sponsors, Dataguise, Mapar, and Prism. Prism is the host for this event. They have provided us this beautiful facility. And I'll introduce Manoj, who bought us this facility, and Manoj will like to talk.
I'll just take 2 minutes. Some of you were asking what we do. My name is Manoj Goyal. We are Prism. We do very big displays. This is a smaller one, which go into TV studios, auditoriums, the new Device Stadium. So we're in the boardrooms and briefing centers of Google, Juniper, SanDisk, Visa, Cisco, AT&T, Comcast, Time Warner, you name it, Boeing, GE. And I'll just show you a 2-minute video what we do, and if you, after the event, you would like tours of our demo center upstairs, I'll be happy to take you. So Praveen, my colleague, who is the head of quality here, he has authored a dozen books on innovation on Amazon, Six Sigma. And Praveen, can you just play the 2-minute video, then we'll go back to the program.
When you're in touch with your information, work flows faster. When you can see the big picture, you make quicker, better decisions. Cascade video walls and displays bring together people, content, and ideas, changing the way we work forever. The Cascade 190 puts the power of an amazing 75 square foot digital canvas at your fingertips. With a simple tap, you can grab a file from anywhere, locally or in the cloud, easily resize and position content anywhere on screen, present and interact with any type of content, documents, images, and videos. Capture ideas by annotating content, making notes, or writing on a whiteboard. On-screen controls for video let you play, pause, take snapshots, and add annotations in real time. Notes can be saved or emailed. To create a bit of structure, you can add snap grids to the background. Several teams can share a wall using projects and workspaces. Their work is saved between sessions so they can pick up right where they left off at their next meeting. Built-in controls let you make video conference calls, pan and zoom a camera, and adjust volume. Multiple live sources can be displayed on screen, including PCs, streaming video, and web apps. Content from a Cascade system can be viewed on any device connected to your existing video conferencing hardware. Cascade video walls work with a variety of cameras and codecs, including those from Cisco and Polycom, and in the future will integrate with Microsoft Link. You can control applications running on a local PC or remote server right from the video wall. Cascade systems seamlessly connect through the cloud, enabling content to be shared and mirrored between systems in real time. The same intuitive collaboration experience is available across the entire enterprise. From the boardroom to the 2-person huddle room, there's a Cascade collaboration solution made for every size space. Bring together people, content, and ideas with Cascade video walls and displays from Prism. Learn more at prism.com.
So all this is in a demo room upstairs. If you'd like to come and play, the wall is cold, you can come and touch. A wall this size runs on less than a hair dryer. So that's a good capability. Okay, back to you. Thank you.
Thank you very much. I'd like to introduce our speaker, Chomoshian. He's the VP of Products. He's been with Mapr, I guess, since the founding. And before that, he was at Microsoft, running their Forefront business. He was one of the leaders there who kind of grew the business. And before that, he was at one of my favorite places, I guess, Carnegie Mellon in Pittsburgh. We probably missed each other by a few years that I was in Pittsburgh for quite a bit of time over there too. So glad to see folks from Pittsburgh here. So Tomer has helped build the Mapr product management team, and now they're all over the map right now, I guess. So without any more taking any more of your time, I'll hand it over to Tomer.
Thank you. It's a pretty cool venue for a meetup. Never done any meetup on a curved screen or a screen this size. Although I have been at a meetup, which was at the Apple Auditorium, where Steve Jobs used to do the product launches, and that had an amazing sound system as well. Okay, so the topic of this presentation is next generation access control and Hadoop and NoSQL databases. So what I'll be talking about is how we view kind of the future for really scaling access control. So when you think of big data, it's not just building infrastructure that can hold all that data, it's also how do we enable people to deal with this volume and these structures of data, right? And so that's what we'll be talking about, approaches that can enable access control and better security in these types of environments. So just briefly, one slide on Mapr. We offer a Hadoop distribution where Forrester ranks Mapr as the top Hadoop distribution as well as the top NoSQL database. We've been growing very, very rapidly. Many customers, I'm sure you're familiar with most of these example logos here. And then also a great list of tier 1 investors. The most recent ones are Google Capital and Qualcomm. So the reason we need to look at things differently today is that data is doubling in size every 2 years. So we have this huge change. So for years, data was growing at whatever rate was growing, let's say a few percentages a year. And then all of a sudden now it's exploding and growing exponentially, and people are capturing every click and every event that's happening and all these interactions that their customers are doing. And so it's we've really started to grow exponentially. The interesting thing here is that it's not the structured data so much that is driving this growth. So yes, you're seeing more and more deployments of SQL, Oracle databases, things like that. But what's really driving the huge growth here is the semi-structured data, right? This is companies that are capturing every single thing that their users are doing. So if it's an ad tech company, then every ad auction, every click on an ad, every impression is being tracked. If it's a security use case, they're tracking all the events that are happening across the entire company and all these log files. And so really a huge volume of data that's happening here, that's being generated and collected. And as we get into the next decade, we'll see that most of the data will actually be this type of data. And so if you think about the challenges that arise from this, is that we've been doing, we've been kind of developing over the last 30 years or 40 years processes and systems that can deal with structured data, right? We know how to define schemas, and then we use those schemas to set up permissions and do all those types of things that we've done forever, right? So we have DBAs, and they manage the data for us, which is great, and that worked for a very long time. But I was talking to one of the CIOs of one of the largest tech companies, and her feedback was the biggest problem that they have in IT right now is that they just can't continue to manage data the old way because the DBA team isn't growing exponentially, but the data is, right? So if IT budget is growing at 2% a year, teams are growing at just a little bit, but the data is doubling in size every 2 years, well then you just can't deal with things the way you used to deal with things. So you require new approaches, right? And you see really innovative companies, like Dataguise, which is here, which are specifically attacking these types of problems, right? They build a solution that's specific to Hadoop to solve these types of problems in Hadoop. So one of the things that has changed, so if you think of from 1970 maybe until until about 2010, maybe a few years earlier, we had this way in which applications were developed and types of data that existed, and that's really undergoing a massive transformation. So in the past, our data volumes weren't that big, right? Maybe in 1970 it was megabytes, grew to terabytes. All the data was very much structured, so it was perfectly reasonable to put it in a relational database and make sure everything was normalized, etc. And then maybe even more importantly, the development of applications was done in a very planned way, right? So you design the application, spend a lot of time planning it out, and then maybe for the next 2 years you'd work on it, and then you'd ship the box to the customers and they deploy it, and maybe they'd upgrade a year later or 2 years later. Well, if you look at a lot of our customers today, companies that are building web applications or mobile apps, they're actually releasing a new version of their app every day. Some of them even multiple times a day. So the need for systems that provide more agility is obvious, right? If you're going to release and change things every day, you need different kinds of tools and systems than you needed when you were changing things once every 2 years, right? And so if the relational databases worked back then, you define schemas up front, and it was okay that it was pretty hard to change the schema because that was an event that didn't happen very often. And that's not okay anymore, right? That's very difficult for this new class of applications. And so what we've seen is the rise of new database or data stores to address this need, right? So technologies like Hadoop and HBase and MongoDB and other NoSQL databases, they're really focused on providing this greater agility and greater scalability to address the use cases and the types of applications that are being built today, where it's petabytes of data, it's a lot of semi-structured data, and sometimes even unstructured data. And then the release cycles are, like I said, on a daily basis, right? These new systems, some people call them schema-free, you could call them variable schema or dynamic schema, there's lots of different names, but the point is it's very easy to evolve the structure of the data, right? It's not something you define manually up front and then have to kind of adhere to that fixed structure, for a very long time, and where changes are complex. In these systems, the application also controls the structure of the data as opposed to a DBA controlling the structure. So it's also a change in who can control that. So as a developer is building the app, changing things, they can go and change the structure of the data. So in this non-relational world, the question arises, okay, well, what do we do about SQL? We have millions of people out there that know SQL. We have hundreds, if not thousands, of tools that speak SQL that people are used to using, things like Tableau, MicroStrategy, etc. So we want to maintain SQL. We want to provide people with a SQL interface that works with all these tools, and they can leverage their knowledge. But we certainly don't want to go back and take away the agility that gave rise to all these new systems, right? We don't want to enforce people to manually go and create and maintain schemas, right? If you think about a system like HBase or MongoDB, where the whole point is that you don't need schemas, you don't need to define schemas at least. Are we now going to say that in order to do BI on these systems or do SQL analytics? No. You actually do have to define schemas, right? You're losing your agility. So that doesn't make sense. We have to maintain the agility that gave rise to these systems. The other thing is we don't want to force people to transform and copy data. If you think about it, even 10 years ago, it was difficult to transform and copy data. ETL was an overhead that not many people liked, right? Well, it's becoming even harder today when you have terabytes and petabytes of data. How do you move petabytes around between different systems and create multiple copies to provide different views of that data, or to give this group of analysts access to all the fields except the credit card information, right? So you create a whole copy of the data set. And that's becoming harder and harder to do. But then, of course, like I said, you want to have SQL, you want BI, you want low latency, and you have scalability. So we went and invested, about 2 years ago, we started a project called Apache Drill, where the whole goal was to provide the first SQL technology that does not require schemas. It's a schema-free SQL engine that allows people to choose on every data set. Do I want to have a schema here that somebody's manually defining, or do I not want that? The idea here is that you can point at a directory of JSON files and just run a query, right? Much like you can, if you're developing a simple app on Mongo, this is the BI or analytics equivalent to that, right? I can point at a directory, query. I can point at an HBase table and say select name from my table. I don't have to go and create table as, say that there's a name, it's a string, etc. I don't have to do all that. And at the same time, it provides SQL, ODBC, JDBC, very easy to use RESTful APIs. So really changing the way in which people approach analytics or SQL-based analytics on these non-relational data stores. And we didn't feel that the right approach was to take what was built in the last decade and kind of port it onto Hadoop. We thought, well, let's look at what's great about Hadoop and keep that and build the SQL technology for the next 10 years or 20 years. Actually, someone came over to my office today and asked me if I saw this new report from GigOn. So this actually came out today, and I hadn't seen it. I said, you should put it in your slides. So there was a new report from GigOn that ranked all the SQL and Hadoop technologies. They're all very different, of course. They all have different sweet spots, but it was kind of cool to see that Drill was ranked the top SQL and Hadoop technology. So what's unique about Drill is that its data model is flexible. This is really how it works, and I'll explain in a second how this is going to enable us to provide new methods of access control. Right? Well, this is the foundation for that. I should have mentioned that in the beginning. This is why I'm introducing this. So if you look at the world's data, you can kind of divide it into these four buckets. So on the top left, you have the relational data. It's flat. It has a schema. Every record has the same fields. There's no nesting of data. You have data that's schemaless. When I say schemaless, some people argue with me. They say, well, it actually is every record has a schema in it. What I mean here is that different records can have different fields. Right? But it is flat, so there's no nested maps. There's no arrays in the fields. It's basically like a flat set of fields. On the bottom left, you have things that have schema, file formats like Parquet, which is a columnar format that has a fixed schema, but it does allow nesting of data, and it does allow arrays. And then the bottom right, you have formats like JSON or ESON or XML, where every record could have completely different structure, and they also support these complex structures, things like dictionary or maps or arrays inside the field. So obviously this is the most flexible format here. And what's interesting is that you can actually represent any of these using, say, a collection of JSON documents, right? I can take a relational table that has a name and an age and a location, and basically create a set of JSON documents that each of them has the same fields, a name, a location, and an age. And that's basically equivalent, right? So the nice thing is this format is, all of these are special cases essentially of this, logically, okay? And so every SQL engine that's ever been built viewed or had this kind of data model, the fixed schema, flat data model, which means that anytime I want to analyze something, I have one of two choices. I have to either convert the data into something that's flat and relational, right? So I have to transform all my data, or I have to manually apply some kind of overlay schema that lets me look at some portion of the data that is then kind of fixed and flat. Drill doesn't do that. Drill is actually the first SQL engine that views the world as a collection of JSON documents, logically, right? You're not going to find anything inside Drill that's actually JSON, right? JSON happens to be one of the supported file formats, but this is the way to think about it when you're querying data in Drill, okay? So you see that we have two records in this case. The first one has an array here called hobbies. The second one has an array that has only one element. They have different fields. This one has a district field, and this one has a preschool field. Okay? At the time, this was where my kids were going to school. And you can see that I can represent something like this using this kind of format, right? But once I have a query engine that views the world like this, I can query any type of data. So Drill can run queries on JSON files, it can run queries on HBase tables, it can run queries on Parquet files, as is, with no predefined, so just pointing at a Parquet file, or a directory of Parquet files, and it can run a query. It can actually now run queries on MongoDB tables without any schema. So really a very flexible schema, or SQL engine that connects to multiple data sources as well. And the other thing is the way schemas are handled in terms of when they have to be, when they're defined. So if you think of traditionally, and this really influenced the architecture of Drill, schemas are in a relational database done on write. So before you load data into the system, you have to define a schema, right? In SQL and Hadoop technologies like Hive and Impala, you have to define a schema before you read data. Somebody's going to go and say the Hive metastore has this schema defined in it, and only then somebody can actually run a query. With Drill, none of that's needed. Drill can actually see or infer the schema from the data as the query is running. So I can just select star on a directory of files, JSON files, and it will just run. right? Or select main from a directory of JSON files. So it provides that greater level of agility. Now, our expectation is that as people mature, right, or as the data matures and people start exploring data, over time they decide, well, this data set, of the 10 data sets I have, this one is probably worth defining a schema and governing in a tighter way, and maybe cleaning it up and making it available to the financial analysts as well. But the 90% of your data that is not governed and can't be governed because data is growing like that, Drill is the only tool that's going to let people look at that, right? It's the only tool that can actually handle non-structured data, semi-structured data, unstructured data, right? Every other tool that forces you to define its structure before you can use it. That also made the architecture very different, right? Because traditionally a SQL engine will compile a query based on knowledge of the schema, and a lot of times statistics as well, right? That's the first thing that the system does when it gets a query. It compiles the query and then runs it through the optimizer. So the ability to not do that, or not have to do that up front, and do that on the fly as data is being seen, and still have really, really high performance, that was really the biggest challenge here. Okay, so now I want to move into, how are we going to leverage this technology to redefine access control, going forward? So if you think about how access control works in Hadoop today, it's pretty simple, right? So Hadoop has a file system, and you can define permissions on files, right? So access control list, same thing. Each file, each directory, you can define access on that. Okay, so these are files, and when you access something through MapReduce or Spark or Drill or any other system, this gets checked, right? The user is coming in, it gets checked whether that user has permission to access that file. If you're using something like HBase, HBase actually provides field level access control. Meaning that you can actually say that this field in there, or column, is only accessible to the data scientists but not the business analysts, right? So that's what I mean by field level access control. And HBase underneath uses what's called H-files. So it's putting files in the distributed file system, but permissions don't really matter on those files, right? As long as the HBase process can access these files, and the user is never accessing these files directly. The user has no need to use Spark or a MapReduce or a Hive query to query H-files, right? That's an internal representation that only HBase cares about. So it's fine, you just set the permissions here so that HBase can access them, and you don't worry about permissions on these, right? So I end up with permissions here for HBase, so the HBase application, permission get enforced there, and I have enforcement of permissions for people that are accessing files. And so all this is great until you realize that there are actually multiple systems here, and you kind of do want to provide field level access control to files, right? So you think of these files, I have a JSON file or a CSV file. Well, what if I have one field that's a credit card, another one that's a name, and maybe I only want to enable access to the name, prevent access to the credit card, right? So I want to provide field level access control, right? The problem is it's not so simple, right? If I just provide permissions, let's say in Hive, right? So Hive knows how to interpret the file, CSV file, into columns, into fields. Well, if Hive does permission enforcement, that same file, people want to access that file with Spark as well, right? Unlike those H files in the previous example, these files are shared across these different execution engines. So now, if we just did these permissions, which is what Hive has, well, all this data, all these field level access control capabilities, nobody else can take advantage of those. Nobody else has access to that, right? So that doesn't really work. And then the other downside here is that we have a separate permission repository. So if you think about whether it's Hive, the Hive Metastore, or other approaches, there's Sentry and for example, another system that does Ranger's another one that does access control, right? So the permissions are stored here in a separate system, even though the distributed file system has its own set of permissions. So now we have different systems that are holding permissions, and that becomes hard.
What is a permission?
A permission repository basically is essentially a database, a separate database. In Hadoop, typically this is like a MySQL or an Oracle, right? That is saying that this file should only be accessible to these users. Or in fact, the first field in this CSV file should only be accessible to the business analyst, and the second field in that CSV file should only be accessible to the data scientists, right? That's what that is, right? So you think of DFS, there's of course permissions also in the file system associated with files. This one is kind of permissions on top of that for the fields, right?
So I know of AAA servers, which do authorization, accounting, and authentication. Is that what it is?
Just the authorization.
Just
Only the authorization, right? So it's not doing authentication. And I'm not saying that this is fundamentally flawed or anything like that. It's a fine approach, right? I'm just saying that there's one of the challenges is that I have permissions in two different places, right? And this is what we have in our distribution today. Right? Okay, so when we look at I started the presentation saying, well, data is exploding, right? So how do we provide new techniques that are going to scale, not just scale from an infrastructure standpoint, but scale from an organizational standpoint, providing people more granularity and flexibility, right? And so I'll start by explaining how it works with Drill, and then we'll expand from there. Okay, so Drill enables you to create views. And think of a view as the same thing as in a database, right? And it's a SQL query, and it can refer to different objects, whether those are kind of raw objects, or maybe other views. Right? That's basically a view. The interesting thing about views in Drill, and we sometimes also call these virtual data sets, is that the view is basically a file in the distributed file system. So you'll see a .drill file, and that's my view. You open it up, you'll see a SQL query in there, basically, with a little bit of extra parameters. So using file system permissions, I can define who can access my view. Okay, so I may own these two files, and I'll create a view that says select only the name and the age from this file, from these two files, and I'm going to enable access to that view to anyone. But maybe another view that exposes more data, I'm going to enable access to maybe a more restricted set of users or groups, right? So that's the point here with views. The file owner or the view owner, right? And these, when I say owner, it's basically the files on the file system. It's that owner of that file, right? That views a file as well. They control access to their data, right? And this is an important concept I want you to keep in mind here. Is this whole thing is modeled after the idea that if I have access to some data, I can share that data with anyone else, right? And that's kind of the real world that we live in, right? If I were to send you an email with a PowerPoint presentation, you can send that to whoever you want. I really have no control, right? So if you give somebody data, at that point, you really can't do much. They can share it with whoever you want. And of course, we need good auditing capabilities to be able to track down and make sure people are behaving the way they should. So let's look at an example of what I mean by logical access control, okay? So we have a raw file. This is, in this case, just put a CSV file, so it's easy to draw here. A lot of times, more complex JSON and things like that. But in this case, there's 4 columns. So there's a name of a person, there's a city, a state, and a credit card number. Okay, very simple data on card members. Right, this is top of mind because one of the largest credit card companies is a very large user of our technology. So I'm going to create one view for the data scientists, and for them, what I want to do is I want to keep the credit card there, but I only want to keep the first 4 digits, right? And okay, so what does that look like? I create a view. I can do this either by just creating manually the view file, the .drill file, or I can just type in the command line, create view. I define the path to that view. This is any path in the file system is fine here. And then I define the SQL query. So select name, city, state, mask. Mask is not something we do, by the way. It's something you would create, right? So a technology like Dataguise, for example, knows how to do masking, right? So that would be like a UDF that gets implemented here from the CSV file, right? And then what the data scientist then views when they are querying this view is they see name, city, state, and they see this masked version of the credit card, right? You see all these ones here. Now this is not a physical copy, so that's what's a little bit different from, I think, how things are approached without technologies like Drill, is that you have to create a copy with a masked version of the credit card. What we enable here is a logical view of that data, right? And then another view here actually doesn't have any credit card column at all. It's just the name, the city, and the state. And this one is for the business analysts, not the data scientists. They don't need that credit card information at all. And so it's just selecting the name, the city, the state from the CSV file, and this one is called members, so part members. Okay. What does this look like in terms of permissions? So the raw data is owned by a user called admin, who's a member of the admins group, and he is providing permissions to access that data to all the admins in the organization. So only admins can actually access the raw data, which makes sense. We probably don't want any analysts or data scientists having access to this very, very sensitive PII data. Then you have this view here for the data scientists, and the admin has created the view, so this view has been created by the admin for the data scientists to then query, right? And so the owner here is the admin, and the permission is data scientists. So business analysts cannot query this view. Only the data scientists can query this view, but this view does have access to the raw data because it's owned by the admin, who's a member of the admins group. Okay, so we're always looking at the view. The owner of the view is the user's is the identity that's getting checked against the permissions of the upstream object. Okay, if you look at this view over here, we have the owner admin and the permission is business analyst, and again the admin can access the raw data because they're a member of the admins group. So you set up the structure, and now in a real world situation you have many views referencing views that reference other views, and et cetera, right? So you have this complex structure, right? One of the things here, so up until I was kind of describing Drill, one of the things we're doing here, with the broader community, is enabling other execution engines to plug into Drill, right? And basically Drill then becomes not just a system for an end user who's writing SQL queries, but it's also the interface to data. So if somebody wants to run a MapReduce job, they can run a MapReduce job and use a Drill view as the input to that MapReduce job. So that would be a Drill input format, right? Same thing with Spark. There's a Drill RDD, so I can run a Spark job that uses a Drill SQL query or a Drill view as the input to that Spark job. And now all of a sudden these views have become a mechanism of providing logical access control, right? I've created a view that exposes, a masked version of my credit card file to all these different systems, not just to end user SQL queries, right? The way this will be implemented is with drill daemons running on every node in the cluster. These execution engines, they can still, of course, read directly from the raw files if the permissions are applicable, or if the permission on the view file enables the user to then read from that view, right? And so this moves us, the reason we call this logical is because it moves us from just kind of a yes-no on each column capability to being able to define these arbitrary expressions or views into data and letting different people and different groups have different kind of restricted views on the data, right? I can control it in a much finer grained way. I also think that what you'll see with these kinds of technologies is that will enable organizations to put much more sensitive data in Hadoop because they have this kind of flexibility, right? They don't have to create lots of different copies of the data. They can really control what each person sees. And you have technologies that can, third-party technologies that know how to look at the data, find what's sensitive, define these masking functions, all those types of things. But they won't have to transform the data in a physical way, which becomes a burden on the customer. They'll be able to essentially do a virtual transformation of the data, or a virtual masking of the credit card information, those types of things.
There is a question on
Yeah.
drill view, which you said for MapReduce,
Mhm.
which you can use as an input. You also described drill RDD.
Yep.
What's the difference
Between the two? Well, very simple. Drill input format enables you to run a MapReduce job on a SQL query. And for Spark, we have the Drill RDD, which enables you to run a Spark job on a Drill SQL query, right?
But that view could be used similarly as to the Spark RDD.
Well, the RDD is Spark's way of getting data in. So you have to build a Drill RDD.
Say that again?
RDD is a way for Spark to get data in.
Yes.
Yeah. So RDD is the equivalent of the MapReduce input format.
Is a data view of an iteration. You have iterated it.
Kind of, conceptually, but it's also the way Spark inputs data, right? It's also the equivalent of the input format, right? So the bottom line though is that when you're going to write a Spark program, you just have one line that says RDD equals drill query. You provide the SQL query, and you say select star from my view, and then that's now an RDB in your Spark program, right? So it's as simple as that. For the user's experience, it's super, super simple, right?
So I'm not going to ask too many questions on this. Just one last point I wanted to make. The reason I was asking that question is map reduce doesn't have that RDB representation, intermediate iterative representation. Does your view technology provide that? That was what I was getting.
Okay, yes. Not only can it iterate the view, like when you're reading it, but it provides a parallelism that you need, right? So very different from if you're using a Tableau, well, I need all the data to come back to a single node. That's one thing, right? But when I'm running a MapReduce job, I have the drill bit, that's our team called drill bit, running on every node in the cluster. The mapper on every node knows how to read from the local drill bit. So you get the full parallelism. So from a performance standpoint, you can saturate the disks.
Does this drill or the view use any database like this Oracle?
No, there's no database at all in the system, right?
Can you bypass that drill and go directly to the data?
Sure.
So
you have permissions,
access
right?
to all the data, right?
Well, no. So if you go back to the previous example, the raw data. So each of these files and views, they all have permissions defined in them. Like remember, the view is implemented as a file in the file system, so it has its own set of permissions. It says, only data. In this case, this view, right? Okay, this view here, which is views/MasterCards, shouldn't have a CSV here. This view is represented as a file. It's a .drill file in the file system, so it has permissions on it, which say who's allowed to query that view. The file also has permissions that says who can query or access that file, right? So whether it's a file or a view, there's permissions that say who can read from that, right? And this kind of ownership chain, we call it ownership chaining, the fact that this view is accessible to data scientists, but the raw data is not. The raw data is only accessible to the admin of the system, right? So that then is how I implement the logical access control, right?
But since the file is not duplicated, this is kind of acting as a pipe.
Right. Right. The file is not duplicated, which is nice because any changes in security or permissions are affected immediately, right?
Right.
One of the challenges, people start duplicating data, well, now I've lost control, right? Now it's somebody took it. It's not that somebody can't take it now, but I'm encouraging a lot less data duplication, right? So the chances of somebody having the copy already in a separate place, or just even the maintenance overhead of having to worry about all that goes away, right?
About this, view is created on fly, because you said view is a subset of the main set, that is the main data store. But if the main data store changes, you have to synchronize between both of them.
No, the view is not materialized. This is a non-materialized view, so the view is really, when I create, at the time of creating the view, there's just a small JSON file in the file system. That's the .drill file. You'll see that if you just look at the file system. We never actually materialize the data here. You can do that, right? It's as simple as doing a create table as, and then doing it. So if I did, instead of create view, if I wrote create table as select, that's basically it. Now I've created a table that has all that data, a copy of all that data, right?
So when I'm accessing the actual data, there are two access I have to do. One is view and then the actual data.
Yeah, the
Isn't
view is...
the latency is increased then?
Usually the latency is not the big issue here, right? I mean, we're talking a lot of data. You usually care more about the throughput than the latency, right? So it's more about providing enough throughput to the data as opposed to...
and also the execution is internally transformed that. So it is basically query transformation.
Yeah.
At the runtime you are query transform. It's not that you are running two queries, one on view and one on the table.
Right.
The query runs on the table itself.
Direct
it's fully pipelined. Yeah.
Oh.
It's just
It's flying. It's flying through, or it's pipelined, right? It's not like we read all the data, then we run the SQL query on it or something like that.
So the way I'm looking at this is like basically think model view controller, right? So the way I see this, like drill is basically playing the role of the view and the controller. And what I mean by that is like, so drill has knowledge of different types of models, different types of data structures. And then it also has knowledge of the different types type of queries that are made by these different types of systems like Spark and SQL. And so basically you've pre-built a program that basically has built a view that uses a controller, that uses a model of some different type of file system, and then that controller also provides knowledge of how you would access that view. That's the way I kind of see it. Because your program basically allows people to create these things on the fly.
Right. Exactly. The transformation is happening on the fly, right, as opposed to happening physically, and then I have to worry about how I keep it in sync.
But then you are increasing storage requirement also, right? Because
reducing storage requirements.
It has increased because you are storing the .view files. These are the files. So.
Well, okay, so the .drill file, the view file, is like 10 kilobytes or something, or 1 kilobyte. It just has it has literally this SQL statement.
It's independent.
It has 200 characters in it, right? It's not actually storing any data. The alternative, actually, the way today things are done is copies are created. If you wanted to hide some information and give one group access to information without the credit card information, I'd have to create a copy of the data without that information in it, right? So that's how I would do it today. Does that make sense?
Yeah. You can operate on unencrypted raw files, right? And so if you can get access to that, of course, game over, right? And the other attack vector I can imagine would be hitting the logic of the executing drill program, that pipelining you're talking about. If you could trick it to say, oh yeah, that's right, we do have permissions for this, and it's over, right? In the code.
So on encryption is kind of what we're talking about here. Well, at least disk level encryption, right? You may be using disk level encryption or volume level encryption that in the file system or on the disk drives, and that's fine. So you're preventing physical attacks, right, through volume level encryption. You can also do things like, if you had some encryption here, you could decrypt. There are all sorts of things you could do. I haven't really thought about that specifically. Tricking the system in terms of your identity to get access to things you're not supposed to get, that really comes down to authentication, right? If you've enabled the wire level authentication, Kerberos, etc., then there's no way to trick it, right? That's cryptographically secure.
Hacking takes many forms.
Sure, find a buffer overrun and exploit that, yes. But yeah.
I was looking for the attack vectors.
Yeah, no, that's fair. Yeah, there's a lot of any of these systems. I think you have huge attack vectors, right? Starting from the Linux to the JVM to the application.
How does this interface with LDAP or AD if customers have that on site?
Yeah.
And they want to be able to leverage some of the permissions that they already saved in LDAP. How is that reflected?
So remember all these files that I have in my distributed file system, as well as these views, which are also files in the distributed file system. The permissions are defined in the distributed file system, which is connected to LDAP, or Active Directory, right? So when you run our file system, or any Hadoop distributions file system, you can connect that to LDAP, right? It'll essentially connect the Linux environment to LDAP. But these users and groups are really LDAP users and groups if you choose to operate it that way. Okay, so there's full integration with actually any third-party directory. We have some customers that use other third parties. A lot of them just use Microsoft AD, but there are other environments as well.
Can you go back to one slide?
Yeah.
On that.
Right.
So here the owner doesn't get the full privileges on the raw file as well as the views. If the owner is that. The owner is that. So then we get access to the file as well as the view. Is that how it is?
So the permissions here control who can access the view, right? The permission here on this is like the ACL or the Linux or the Unix permission on this file, right? So in this case, anyone who's an admin can access the raw data. I'll get to chaining in a second. But okay, so we talked about how we extend this to other execution engines. One of the really nice things here is because this is based on the Drill execution engine, right? This doesn't have to be limited to Hadoop, right? Drill knows how to query MongoDB, for example, and people are now building integration with Cassandra and a few other NoSQL databases. So in MongoDB, the tables are called collections because they're a collection of JSON documents, and Mongo has its own permission system on these tables and columns here. So if I have a view that is doing a join between a directory of log files, JSON log files in Hadoop, or text log files in Hadoop, and a collection of user profiles or products in my product catalog in MongoDB, that view is an object, right? I can define whatever access control I want on that view. So I may say, well, the business analysts can access this view, and the fact that underneath the hood, this view is then accessing data in Hadoop, and data in MongoDB, and data in Cassandra, and whatever other systems, that's perfectly fine, right? To the end user who's running a Spark job or a SQL query, all of that is transparent, right? They're just seeing a SQL view coming from the system, and the permissions are set in the distributed file system. So basically, the distributed file system where I have permissions, and I have to manage permissions anyway in my distributed file system, that's the only place I now have to manage permissions, right? There is no third-party system where I have to manage permissions here, okay? So this is kind of an interesting topic here, which is how does data get shared, right? What rights do people have to share data? And so the rule that we're following, which we think is kind of nature, right, is if you have access to data, you should be able to share that data with anyone else, right? Just like the example I give you, if I send you a PowerPoint presentation, well then there's nothing I can do to prevent you from sharing that, right? In fact, if I gave you access to some view, you can share that data even by just dumping that view into a file and sharing that file, right? So I really, we say it's nature because there's nothing I can do to prevent it. It's just, that's the physics, right? I gave you access to that data. I don't know what you did with that data. You could have put it on a USB drive and sent it to somebody, or you could have done a create table as and selected that data, put it in a different file and shared that file with somebody, right? And so there's really two ways you can share data. One of them, let's say you have data in A, B, and C, and these could be files or views. I can do a create table as select from these files or views, right? And I've essentially created a copy of the data at this point with a create table statement. T is now a Parquet file or a JSON file, whatever's configured. Now to do this, the owner or the creator of T must be able to read the tables or the views A, B, and C, right? I can do this in a non-materialized way with a view. I can do a create view V as select something from A, B, and C. In this case, the owner of V must be able to read these tables. The difference here is that the permissions here are not being checked at the time that the view is created, of course. They're being checked later when the query actually happens, right? As opposed to here, the permissions are checked right now. I'm creating a copy of the data. Permissions get checked now, and that's it. There's another table. There's a new table in the system, or a new data set. What we do have to provide here in this kind of system is strong auditing capabilities, because people are going to want to know who shared the data with who sent the data to who. So having really good auditing and good management capabilities around that is important. The owner of an object gets to decide whether they're, so one extension to this that we're thinking about is enabling the owner of an object to decide whether their object can be referenced in other views. So you kind of, an extreme example would be I give a view to my call center guy, well, I probably don't want them to be able to share the data beyond that, right? So we are thinking of, should we restrict kind of beyond this kind of nature rule, right? And the way that would work is through like essentially we call it a TTL. So how many kind of jumps can you have here, right? So I have a file that's referenced by view 1, referenced by view 2, referenced by view 3, and then user X is querying the data, right? So let's say the owner here is Z, and the permission here is Z, okay? And then there's a view here that the same person created, and they're providing permission to some other person, Y. And that means that this view that's owned by Y can access this view, right? This view that's owned by Y can access this view, because the permission here is Y, and the owner here is Y. And then permission here is X, and user X is querying the data. So the whole chain works, and it's fine. But do we provide the ability for, let's say, the owner of the file, or maybe it's a global thing initially, to say, I only want a TTL of 1, right? Or maybe I'm okay with a TTL of 2. A TTL of 2 would mean 2 ownership changes, so Z, Y, X, right? So a TTL of 2 would enable this to work. TTL of 1 would not enable it to work, right? So it's really about how much do I trust other people to keep sharing. And that doesn't really provide like hard changes in terms of what's enabled from a security standpoint. I mean, if you're kind of a secure, like a cryptography guy, authentication guy, you'll look at this and say, well, there's no fundamental difference between just enabling all of this and not. But there is something about, you know, how easy something is, right? And that's what this is about. So.
Quick question about this.
Yeah.
When you say permission on the view, there's two bits that some of us are worried about. Does the view exist? How do other people know it exists? And the second question is, how do they get the data from the view? So with the file system, when you say the concept of sharing, does that mean that you're adding other members? Are you adding a group file system bit that says allow them to read write, or what do you mean by sharing?
Okay, so how do they know the view even exists? That's outside of the scope, right? So, you know, how do you know, if you're using a database, how do you know that a view exists? You could describe the tables and the data, show the tables in the database, and you'll see the views, or, you know, somebody wrote a document that says, here are the views you should care about, right?
And that currently is accessible to the building. Describe the command.
Well, yeah. So again, the views are files in the file system. They're .drill files. So you could do something as simple as a find command on the file system to list everything in the file system. And if you want, you can do a grep .drill on that and find all the views in the file system, right? Oh, that's not something that we solve in any specific way, right? If you think about it, a database is, you know, has a namespace, right? It happens to be a flat namespace. There's no slashes anywhere. The file system is somewhat the same, right? Yeah, it does have slashes, so it's kind of a hierarchy, really. But at the end of the day, there's a list of objects in that system, right? They happen to be called files, and here it's called tables and things like that. But fundamentally, there's a namespace, and there's elements in that namespace, right?
So we can read the drill file and find out where all the credit card numbers are, in which raw file the credit card numbers are stored.
You could find out only if you have permission for that view, right?
I can list all the drill files and...
Yeah, well, first of all, your ability to list the drill files depends on the permissions on the directories, right? So you may not even be able to traverse all the directories, so that kind of depends. And your ability to view the .drill file, the permission of the .drill file, control both whether you can run a drill query on that view, and also whether you can even view that file, the .drill file, right? Think about it, it's a standard file system permission, whether ACL or kind of Unix posits permission, but it's actual permission on that file. So, and we're talking about the read one. So you asked, I think,
right,
which bit, right, or which ACL.
So was it the group of the user? So you're basically saying if you want to give access to multiple users within a view, it's allow a write permission on a group, and then add members to the group. And anyone who's a member of that group should then be able to access the drill file, which means run the query.
Yeah, so we only care about the read permission. Drill doesn't do inserts or updates. So we only really, I mean, it does create tables, which is a creation of a file. That's really permission on the directory. But Drill is really centered around querying data, right? So what matters is the read permission. That's the only thing we care about. You are right that with POSIX permissions, you're a little bit more restricted in terms of, you know, what kind of, how flexible you are in defining, right? There's only one group that you can define there. And, you know, with ACLs, you have more flexibility.
But, I mean, this is really powerful because what you do is you can add a group on that view, you name the group, and then you can add users to that group, and you can create a really powerful permission system.
Yeah. Yeah, in fact, you know, interesting you bring that up. One of our larger customers, they have actually built a system in the past so they run our Hadoop distribution on over 2,000 servers, or no, it's 1,800 servers. And they built a whole provisioning system for their analysts. So this is exactly the problem we're trying to solve, right? They have people with different rights or different roles, and that person wants to come and they want to request some data set, right? So it's essentially like checking out these data sets. but today it's all physical copies of everything. So the analyst gets their physical copy, based on all the checks that were built in their custom system. And so they're very excited about this because they can, go from kind of all these physical copies to a more kind of logical or virtual type approach, right? And have all that flexibility, the granularity to say, what exactly can different people do, and it doesn't have to be limited to yes or no on a call, right?
So quick question there. So that check is actually, so you're trying to distinguish between I guess, ease versus cryptographically sort of more secure.
Between what?
You sort of peripherally mentioned the distinction between the ease of access versus being necessarily cryptographically more secure. Right? So can you elaborate on?
Sure. So the tightest security guarantee that you have here is if I give you access to some data, you can do whatever you want with that data. And there's nothing in the world that is ever going to change that, right? Because I give you access to the data, and you take a picture with your camera, right? Share that with whoever you want, right? You have lots of ways in which you can, no matter what system you put in place, you're going to be able to share that data with other people, right? That's why you send a lot of people share like presentations with other people, and they put confidential and don't share and stuff like that. And then I get those presentations in the email. People ask me for my opinion, right? You probably weren't supposed to send me that, but that's just how it is, right? Now, what we are looking at doing here, or considering, is enabling it, or making it a little bit harder for people, right? So it's not going to be any kind of bulletproof thing that's going to guarantee that people aren't going to share that data, but if I want to create a view of some restricted view of data for my call center guy or some business analyst, some junior business analyst that's doing an internship right now in the company, right? I don't want to make it easy for them to share that data with his friend in some other department, right? So I'll make it so that view, it would not be possible to create another view that references the view that I provided to him, right? He would not be able to then go and create another view on top of my view and share that with a different set of people, right? That's what I meant. Right, so we call that a TTL because it's how many ownership changes are you allowing.
Right. But what I was trying to ask is, so the way you described it, it does sort of prevent you from doing a certain set of actions, right?
Right.
But then you sort of threw in this caveat which sort of said...
All I meant is that business analyst, that junior business analyst, who I gave access to the name and the age information, the name and the city information, he's not going to be able to create a view to share with other people in other departments, share that data, but he will be able to just copy paste that data and put it in an email and send it to his friend. So I can't really prevent cryptographically or anything like that, prevent him from sharing that data. Right. I can make it harder for him, right?
What's the max limit for TTL?
There shouldn't be any fundamental limit.
TTL represents number of owners.
Right.
Not a number of views.
Yeah, so that's a good point. So it's really the number of owners, right? Because if it's the same person, like the same person, just to massage the data and kind of play with it and get into the shape they want, they should be able to create 100 different views and just as their own implementation, right? You want to build an iPhone application. You don't want somebody telling you how many functions to put in there, right? And then you'll end up in one big function, right? That doesn't make any sense. So let people use the tool for what they need, because that doesn't represent any conceptual change, right? They're just using views.
So TTL can be as number of owners.
Right.
Yes.
Yeah.
Does it provide access control only to the file system, or if a table is there within a MongoDB, can I have the control?
Yeah, absolutely.
Table also.
Yeah. Well, so yeah, it doesn't really matter. You can probably the first implementation actually be a global thing. So what's the TTL in the system total? And then we'll doing this at a per object level, right? Like on the file or on the Mongo table or on the view.
Can I have the number of servers?
Per server, you mean?
Yeah. For example, I have 2,000 servers. I want to control access to that server.
Well, so Drill is a distributed system, right? You actually don't know in advance where each piece of the query is going to run, right? So it doesn't really make sense to have a different policy on different servers in the system, right? Access control for the server is a whole different topic, right? If you just want people to log in or not log into the server, that's Linux work. That's just Linux access control.
Drill is the drill subject to Carbo's single sign-on and LDAP, or it is totally different?
This is all.
It is not a substitute, right?
This is all right. It's orthogonal.
How does this work when you get up to the application level? Because wouldn't the application want sort of a consistent, I mean, I understand when you're poking around, you can see what you can query or not, but wouldn't the application want a consistent database to hit against?
What kind of application?
I mean, a BI application. I'm just trying to understand how that stacks on top of this. If I had, items, Tableau, etc.
So you're asking if I have a BI application, wouldn't I want a consistent database?
Well, I'm just trying to understand if I'm an analyst. Let's say there's 4 different grades of analysts.
Yeah.
And they're entitled to 4 different levels of information.
Right.
But they all have Tableau, or pick a BI tool, and they want to analyze the data. How would this help them get 4 different views of the data in Tableau?
Yeah.
As opposed to, I mean, I understand when they're poking around with what queries can I run, what views can I...
Well, based on this model, maybe I'll see if I understand correctly. Analyst group number 1, release, the ones with the least permissions, they would access view number 1. So they'd be told you should look at.
I see. So you'd point at a
different data sets,
specific
yeah.
view,
and they would not be allowed to access others. Could we do something where it's kind of like it's like a per user sibling kind of thing? Is what you're saying? Like different people are seeing different views essentially of the data transparently, right? That could be interesting.
So it's only the admins who can create these drill.
No.
Because otherwise you won't have permission on that data.
No, I mean, the raw data doesn't have to be owned by an admin, right? Like, in
So
fact,
if it's sensitive, then you don't want everybody to see it.
well,
Then
it's whoever had access to that raw data. I mean, we have some of our customers are in the healthcare space, right? One very big health insurance company. I have 20 different departments using the cluster independently. Same cluster, but they're each using it independently. Each of those departments has their own people, their own admins, their own people that are bringing in data, their own data engineers, right? And so they may own the raw data in that case, right? It's whoever writes the raw data owns that raw data, right? And
no, but then each view that's created has to be created by a person who has permission on the raw data. It's not that you can say define it on the data piece itself, and then anybody who accesses that piece of data is automatically protected.
No, absolutely, you're correct. If that admin brought in that data, they need to provide permission on that raw data to whoever should be able to access that raw data. Now, if they only want to provide a restricted view on that data, then they would themselves create the view and provide broader permissions on the view, not broader permissions on the raw data. They keep the raw data really restricted only to themselves and provide a restricted view that provides more flexible access or more broader access.
But at what point is that view access checked?
Execution time, when somebody is actually coming to read the data.
So, in the example that we were just talking about, what is where you want to sort of essentially couple the user who's logged in with a specific set of permissions depending on the group that he or she belongs to.
Right.
So you would dynamically create a view there, or
no. So let's look at this example again. Okay. So I have this view called /views/mass cards. So it's mass credit cards, right? That's what this view is called. And the permissions here are enabling anyone who is a member of the data scientists group can access this view.
Right, but where is that list?
This list is defined in LDAP. The company has a LDAP group called data scientists, right? But it's defined in the ANCL in the file system. The permission on the file, on this view file, is set so that this group has read access to the view. Okay? Now, when a data scientist called John comes in and he wants to get access to this view, right? the system checks and says, okay, well, he's a member, John is a member of the data scientist group, so you can access the view. It then says, okay, the view conceptually is running as the user admin, because that's the owner of the view. And so this view, which references the raw data here, so this view has a select from the raw data. The view itself is conceptually running as admin user. So the view can then, it's okay for it to be able to read data from here.
Right. So in this case, there'll be sort of 4 different LDAP groups with a category.
Right, exactly.
But the
which is here you see two, business analysts and data scientists. So yeah, you can add something.
The problem I see is that the data scientists may own the data or may have the thing to look at the data, but in this case it seems like they would have to be system admins, or there would have to be admins on the system in order to create views to view that data. And those admins may not know exactly what sort of data it is and how it should be masked and how.
So you could just replace this with data engineers, right? Just call this data engineers instead of admins, right? Just call this data engineers, and that's all, right? So maybe it's a bad example to use the term admin because people are concerned with the IT guy shouldn't actually have access to the data, things like that, right? So
it's the creator of the data.
Essentially, yeah. And again, the creator doesn't have to be, maybe transferred to someone else, but yes, whoever kind of owns that data, the owner of the data.
Quick question. So, one question I want to ask is, if there are multiple views of the same data, and let's say I don't have any permissions, right? And I say no 4 data scientists. One of them got the name, one of them got the city, state, credit card. I can take all these views, because you said if you have the data, you can share it with anyone.
Yep.
I can recreate the raw file itself. So,
how would you create the raw file?
If I just get the names from one data scientist,
yeah,
right, and I can get the cities from another data scientist,
yeah,
and if they are willing to share that information with me, I can potentially recreate the whole raw data set, right?
Yeah, that's correct. That's kind of like
what people involved.
Yeah.
So I don't have access to proprietary cables of the State Department, right?
Yeah.
But Edward Snowden did, right?
Yeah.
And then he decided to share it with me, right? So now I got access. Now it's nothing the government could have done to prevent him from sharing it with me. They should have done a much better job preventing him from getting access to that data, right? But once it was in his hands, as you've seen, it was pretty easy for him. He met with a reporter, gave him a CD-ROM, right? That was pretty easy. There's nothing they could have done to stop that, really.
There are a few other things also. One thing is that union of all the views does not necessarily represent the.
That's correct as well.
That
Yeah.
is one factor.
Yeah. In fact, in this example, there's no way to get the credit card information.
Some of the columns cannot be covered in
Yeah.
any of the views. That is one possibility. The
Yeah.
second possibility is that this kind of masking. So no view can give you access to a raw data in sensitive columns, particularly.
Right.
So again, you cannot achieve that. So, but theoretically, there will be some situations when it can be done.
Yeah, and actually, the other thing we're excited about this kind of approach is that there are a lot of companies now that are kind of focused on data preparation or data transformation, right? In fact, that's one of the things Dataguise, who's hosting this meetup, they do is they mask data, right? It's one of many things, but one of the things they do is they mask data, right? So this kind of engine enables companies like Trifacta, they do just data preparation transformations, right? So all these tools can do exactly what they're doing, but now they don't actually have to do that just the actual physical copy of the data, right? They can create the logic, the functions, all the logic that does it, right? And then enable people to have access to mask data, right? So this is kind of the engine. It's not, it's still up to you to figure out how you're going to mask, what function you're going to use to mask, what transformations you're going to do. That's still something you have to develop, right? Or figure out how to do.
So the drill ACL in that was write or update permission or do allow permissions?
Only about read. Drill doesn't do inserts or updates. And again, it's not drill ACLs, it's file system ACLs. Right? Drill's just leveraging those.
So
you know, as a security provider, we spend some time doing masking, we spend some time doing encryption. At the field level for encryption, you know, sometimes we look at things like UDFs for Hive. We think that's kind of painful, you know, that assumes that anyone writing a Hive query knows sort of a priori which fields have been encrypted. So we're doing some work to try to make that a little more transparent. And in this whole model, if Drill were accessing a CSV file in which the credit cards were encrypted, what will you do? How will you get an decryption function, and can we work together to try to make that more transparent than having every view writer have to know a priori which cells were encrypted?
Yeah. No, my vision on this is that there would be tools, right, that would, you know, like detect what data is encrypted, automatically create views, things like that, right? So the view is the capability, and you get to more, some things are simple, right? You're only exposing the name, city, and state, but not the credit card number. Yeah, a human being can do this. Well, there is no like out-of-the-box masking function for a credit card, right? Or a decryption thing, right? So that's something like Dataguise can provide, right? In this
but the framework for UDF is there today?
Yeah.
So between the table and the view that you talked about, is there any difference in terms of the create table and the create view that you had probably on the next slide? Is there any difference in terms of performance or latency or throughput, one way or the other?
Well, so certainly this command, just this command itself, is going to take a lot more time than this command, right? This command is actually doing the work, right? And writing it into a file, writing it into the table. This is actually selecting all the data and writing it out to this file, a Parquet file. This isn't actually transferring any data when I run this command. And this command is simply defining a simple view.drill file, remember that 200 character file. Now, if you take into account later somebody queried, let's say you do a select star on this versus, and then you write it into a table, the files instead, or you just do this command, that's going to be the same.
Well, what I was trying to find out was, let's say you use the table, that's doing a snapshot in time, or is it still runtime?
No, this is a
snapshot in time, right?
Yeah.
So if the data's changed, then you're going to see, a view safer than ever materializing the table.
Yes, this is not materialized. This is materialized. The moment you ran this command, you now have a directory of Parquet files or JSON files based on what you've configured, and that's it. That's a new data set.
So we have sort of a quantification of the impact of doing a query and a drill, or is it fixed, or does it depend on the area?
What do you mean by doing impact of a query or drill?
Well, so clearly there's some latency in sort of filtering that, permissions constraint.
Right.
And if it's some complicated, elaborate scenario, then you could say that, maybe if I knew that, then I would optimize my query processing in some way.
Right. Yeah. So first of all, I think there's always that kind of trade-off, right, between I want to do things simple on the fly versus I want to really optimize for performance, right? I mean, at the end of the day...
Right, so I'm not complaining, I'm just saying it's sort of a quantifiable...
So at this point, the integration of Drill and Spark is in Drill and MapReduce. It's still kind of alpha level, so we haven't really focused on the performance there yet. The Drill queries itself, we are focused on performance, and we have very, very high performance for like a SQL query on Drill on data, right? So that will be something like this will be very fast, something like this will be very fast. And I think integration with Spark is still, there's more work to do basically, integration with MapReduce. It kind of work functionally, but there's more work to do there. But yeah, I do expect people to look at that trade-off and say, and I think you see that all the time, right? You see it, the tools. Do I get a Tableau extract and import data into the Tableau in-memory structure, because then I can slice and dice faster than if I do direct queries, live queries on the back-end data source. But if I took an extract, now I have to refresh it every so often. So there's kind of trade-offs in these things, right? Performance versus usability or easiness.
No, and basically, whatever you're doing with your drill, it has to do all of those permission checks. So that is a fixed cost. Whether it's a relational database, non-relational database, this case, you're on dual query engines. Because you have the Spark query engine and Drill query engine. I think that's the real key. Right. The Drill query engine is really fast, which is what I think you're talking about. It's integrated with Spark. You can optimize there where permissions are flat costs, but you're trying to optimize the query execution costs.
Right. Exactly.
It's like putting an ODBC driver, a bunch of ODBC drivers in the middle.
Yeah.
That.
Yeah. Actually, I think what people will find is the convenience of being able to, of this integration between Drill and MapReduce or Drill and Spark is very, very beneficial because we see a lot of our customers when they run a MapReduce job, the first thing they're doing is, or a big portion of what they had to hand code was stuff you give them in a SQL statement in like 10 seconds, right? It's like filtering something and grouping by something, right? So just that alone, ignoring all this whole permission thing, right, is a really nice benefit to MapReduce programmers.
So views are only for read only, right? There is no, you are not giving permission to write or update.
That's right. If you want to, like, when you're writing something into the system, so when you're writing something like you are here, then the permission, this is really creating new files. So the permissions that matter are your ability to write to the directory.
So view only represents read permissions, that's it.
Correct. Yeah, your ability to write new data into the system
or update data.
Or update data is, yeah, that's like the file. So you can't, essentially the point is you can't write through a view, right? So when you write to the file system permissions work. So it is what you would expect, right? In terms of, you have one repository of permissions, which is the file system. And that, when you're writing data, it's file system permissions, which is write permissions on directories, control the ability to create a new file, write permissions on a file, control the ability to update a file. Just kind of what you'd expect, I guess.
Here's a question. I'm a little bit confused, and I'm not a database guy who does it for a living. When you talk about RDD, Spark RDD, and you're talking about an intermediate data which is there in MapReduce, is your notion that the two are the same things?
No, MapReduce and Spark are two different execution engines.
Yes.
An RDD in Spark is essentially an abstraction of a collection of data, right? It's not actually RDD is in itself a data structure, right? There's actually, Spark has many different implementations of the RDD interface, right? And so, you have, I think it's called a row RDD or a schema RDD is what Spark
is. You could have a data set, and you could use MapReduce on that, or you could use some machine learning algorithm and RDD, right? And those are two different execution technologies.
No, that's all Spark. That's all what I would consider Spark. So MapReduce is separate from Spark. There is like a map and reduce function within Spark, which is a completely different. That's not what I meant when I said MapReduce here. This is the Hadoop MapReduce execution engine that runs directly, not on Spark, right? And this is Spark. Within Spark, you have different functions you can run. It kind of is this MapReduce thing, but it's just a function in Spark. It's not. So yes, you have an ID, you can run a map on it.
But the RDD that's coming from MapReduce is a different thing.
There's different RDD. There is no RDD that comes from MapReduce. Oh, within Spark,
within Spark, yeah,
is different from other RDDs.
Right.
Yeah, and the RDD that comes from Spark SQL is a different type of RDD as well.
Anyway,
right? Like the RDD that comes from Spark SQL is called a schema RDD.
So this is a dumb question. Let me just ask you one thing. Say you had a data set, and you said, I'm going to run MapReduce algorithms. I'm going to do all the things like sort and shuffle and aggregate and reduce, and I'll come to an output through an intermediate data.
Right.
That is an algorithm you used using MapReduce, right?
Correct.
Then, let us say hypothetically that you had a machine learning algorithm, and you could use the same data and feed it into that, right? It's possible, it's very possible. You will find a mathematical model which will accept the same data model which is fed into MapReduce. Right? So now you have two different applications running on the same data. My question is, one is using Spark RDD, which is in memory, and another one is using your MapReduce.
is there a way to reconcile those two? Meaning, can you have just one file which would be used by both through views?
Yes. Well, even without views, you can do that, right? Actually, that's the common pattern in Hadoop is you have data in Hadoop, and different people are accessing that same data in different ways. A lot of times in Hadoop, you have the same file, and one guy's running a Hive job on it, the other guy's running a MapReduce job on it, and the third guy's running a Spark. I'm exaggerating, most companies don't necessarily put all of these, but there are companies that do, and certainly multiple execution engines is becoming the norm. Right? It used to be Hadoop only had MapReduce. Now it has multiple options for execution engines. One of them is Spark, one of them is MapReduce, one of them is Drill, one of them is Impala. There's different options.
But if the execution engine is not the same, and the data models for the two are not the same, then you cannot use it.
Yeah, I mean, it's kind of application specific, whatever your app wants to read as a file, right? Just like on my laptop, I can have two different apps reading the same file, or I could have two apps reading different files.
Thank you.
Any other questions? So I think that was actually my summary slide. So just to summarize, I think some of the advantages here, it basically taking us to this logical world where you're not creating physical data copies or silos, very, very granular. You can share different things with different users, including functions on the data. Very integrated into your existing environment, so there isn't a separate permission repository. You get to reuse Hadoop file system permissions as well as LDAP or Active Directory or whatever authentication repository you have.
That point, Hadoop file system permissions, LDAP, you're using it for write and update permissions, right?
As well, yeah, okay. And for the read. And then self-service with governance, and this really comes down to, actually all these things come down to, we have a lot of data, we have to enable people to be more self-service, right? It's not going to work. The tight control of the DBA to manage all the data isn't going to work anymore, right? It's just, we have to embrace new models. So with that, like I said, Drill, Spark integration, Drill MapReduce integration, our beta will be coming soon. A lot of different resources you can learn, download, etc. Thanks, everyone.
Stop now.
Development material.